Hello friends, today we are going to discuss about conic sections, our part 2 of conic sections. First part, if you want to see, you can see my last video in which we did practically how we can plot conic sections by cutting a cone with the help of a plane at different angles. So we'll get different conic sections. Mainly there are 3 conic sections: ellipse, parabola and hyperbola, and a circle is a special kind of an ellipse only. So today, as I've told you in the last video, that I am going to plot it geometrically. So today's video is about geometrical representation of these conic sections. So we can see one by one. First we will see about a circle, how we can plot a circle geometrically on a graph paper. So it's very interesting if you see how we are going to plot it. So let's see the first definition. As the definition says, the circle is a curve traced out by the point that moves in a plane so that its distance from a given point is constant. Means if one point is given to me that we can take as center, and we are tracing out a curve from another point which is moving in a plane so that its distance from the center is always fixed or constant. So we can see on graph, if you will see how you are going to plot this. I have made a center for you. This pin is actually a center, right? And this I am taking a moving point. See, I will take a point. This is a point where my pencil is pointing. If I move this point in a plane, right, I am going to get a circle, but that point has to be fixed, right? So just a neat circle, if we'll say. So it's just a neat circle. So if you'll see, I have taken a point in a plane. If I move this point in a plane, I am going to get a curve which is actually a circle, and a distance of this point from the fixed point center is always constant. So this was a circle, our first conic section, right? Second conic section, if you see the definition, what does it say? It says that second one is an ellipse. So ellipse is a plane. What kind of a plane curve? Surrounding the two focal points. Now what are the focal points? They are two fixed points, you can say, two fixed points, such that for all the points on the curve, the sum of the two distances of the focal points is constant. Which means what? If I take now two fixed points in a circle, I was taking a single fixed point. Now if I take two fixed points, right? If I take two fixed points and I will move in a plane in such a way that sum of the distances of the point from both the points is same. Means if I take 2 points, now I have taken these 2 points. You can see the pin heads. So these pin heads are actually the foci, right? And this pencil point is a point on a curve, on the curve which we are going to make, that is an ellipse. So he is saying that distances from both the focus, sum of the distances from both the focus, that means first focus and this point distance, this line, and the second focus and this point, that means the second line, sum of these two lines is always constant. So that means if I move this point like this, slowly, I am going to get, oh my god, an ellipse. So you can see a bit moved, but it is an ellipse, right? So if you'll see, this is an ellipse, right? So if we move it once again, if you want to see it clearly, I'll move it for you once again, and you can see it clearly. that the kind of a shape it is making is actually a ellipse. Right? So this is the shape it is making. So it is actually an ellipse. So ellipse is what? It is a special kind of circle or elongated circle, you can say, right? So this was an ellipse. Third shape which we are going to make is your parabola. Now what is a parabola? This is very interesting. Now you can see parabola is a locus of points, right? It is a locus of points in that plane that are equidistant from both the directrix and the focus. Now what is a directrix? Directrix, if you see, it is a line, a straight line. So if you can see, if I have a directrix like this, so it is actually, if you see, I have a point, focal point, and a directrix, right? So this is a focal point and a directrix. So he is saying the distance from the focus and the directrix is same. So if you'll see this center point, right? If you'll see this point, distance from the foci and the directrix is same, right? And if I want to take some other point here, so if I'll take, suppose distance means always a perpendicular distance. So if I take this point, so distance from here and perpendicular distance till here, these two lines are always same, equidistant, right? Again, if I take another point here, so the distance from this point and this line is always same. So like this, I'll get a point, set of points this side, and I will get set of points this side. So I'm going to get a parabola, right? So this will be a parabola, right? So this was about parabola. The last one is hyperbola. Hyperbola, how we can prove geometrically is, hyperbola says it is a set of points such that for any point P of a set, the absolute difference of the distances is constant. Means distances of a point and the foci. So if you'll see, I have made a hyperbola for you, and two foci are these two black points. That means your pin's heads. If I'm seeing, you can see. So he is actually saying, if I take any point, suppose this is the point P, right? So if I take this point, so distance of this foci and this point, and distance of this point and the second foci, both the distances, means this is F1 and F2. If so, PF1 and PF2, the absolute difference of both the points, means if I subtract both the distances and take absolute value, that is always constant. So if I take another point Q, so this distance F1 and this distance F2Q, both the difference between both the distances and its absolute value is always equal to what has come from the point P, and similarly from any other point. So that is what is saying, a set of points such that for any point P, the absolute difference of the distances is always constant, right? So that means the absolute difference of PF1 minus PF2 and the absolute difference of QF1 minus QF2 is always same, any point, right? So this was about geometrical representation of these conic sections. For more such interesting geometrical and mathematical videos, keep watching, keep liking, and keep subscribing. And for the